Hi everyone. So, achievement hunter and Lego influencer Jack Pattillo, he recently bought this LED light strip that I'm kind of showing here, and he was trying to pair that with an Arduino electronics kit. He recently did a stream where he's got everything hooked together. He's trying to do some programming to control how the light effects work, and what he wanted to do was get this effect where it would fade from red to green. But just working on stream, had a bit of trouble with it. So off stream, I started looking at some of the code, and I wrote some simple code that I think should achieve the effect. And I just want to do this quick video tutorial to kind of step through the things that I did and hopefully explain, what I did, why I did it, and hopefully have it make sense in a way that Jack or anyone else can use it as a foundation and build on it to control the lights in the way that they want. A couple of disclaimers up front, right? There's thousands of ways to code anything. I'm sure lots of people will have different styles and ways that they can implement the code, and that's a great thing, so I'm just showing off mine. The other disclaimer I have is I don't actually have an Arduino kit or this actual light strip that Jack was using, but what I did find was online there's a simulator that someone wrote online, and a credit to Walkwe who posted this out. It basically lets you simulate virtually. You throw your code in here and it sends it to this virtual light strip. And that seems to work pretty well for me, at least in testing. Hopefully it'll work for Jack as well, but this is at least as far as I'm able to test. So let's just dive into it. So the code that I wrote, obviously the header stuff needs to be configured for your individual set of lights. I kind of copied the code that Jack was using as the default for a number of lights that he's got in his strip, the LED light type, and then the color ordering of how the particular strip he's using interprets light. So in his case, he writes colors in the format blue, red, green apparently. The default template for the simulator uses green, red, blue, and it's simulating this 2812 strip. So headers will be a little bit different there when I'm running in the simulator. But you can use the rest of the code. It should be pretty much copy-paste. So I wanted to step through real quick kind of the structure of the code itself. For purposes of the Arduino and using this FastLED library, there's the setup function at the top, what you call, this is basically the one-time instruction code. So it gets executed when you power on the Arduino. A lot of people, I guess it's not always required, but they put a delay at the very beginning, so 3 seconds, 3,000 milliseconds. Basically just pause at the start of the code, give the time for the Arduino to fully boot up so you don't have any odd behavior, and then we run the standard FastLED command to basically register all the lights in the strip based on the number of lights that we defined up at the top, and then set brightness, which should default to 255, the full brightness, but not required. And then the loop structure is what you would normally consider like the main function of the code. So this is the code that the Arduino is constantly going to be executing in the background, right? If you've written a program before, you probably had a main statement where you write the code and it kind of runs, a bunch of executions, and it gets to the end, and that's the end of the program. It's done. Arduino, right? It's a microprocessor that's constantly going, and so the way that you can send commands to it is you have this loop statement where it'll basically run through all the code in this function repeatedly. So it gets to the end and then runs it all over again. And the reason is, right, you want that microprocessor to be able to respond to input. So you have to, have code that basically takes input commands or events. Something gets sent to it via Wi-Fi, you have a microphone connected to it, whatever, and then you react to it in that code, send different commands, outputs that, send commands from the Arduino to whatever you're wiring it to. So in the case of a light strip, you would send those commands out to change the colors of the LEDs. You could write the commands directly in the loop statement itself, but what I did was I basically created sub-functions or separate functions to control the lighting in different methods. So I wrote, for this sample, I wrote 3 different functions: pulse red, one called fade to green, and another called fade to green underscore v2, so version 2 of it. And they function a little bit differently. The reason I did it that way is when we, looking ahead at whatever we're using for the live code, eventually, right, we're going to have this hooked up to the LED strip, and we'll have it, you know, doing this fade to green. Maybe they'll be going constantly in the background. I think the idea that Jack has is eventually, you know, a twitch alert will go off, or he presses a button on his soundboard or whatever, and then it'll trigger a different color command. And by putting things into a function like this, it makes it easier in the future to basically switch between those different color patterns. So for the purpose of the sample here, I can just comment and uncomment these to switch between them. In a full project, you're probably going to have some other variable that kind of tracks everything and then switches between these on the fly. And there's some samples in the FastLED library that kind of show how to do that. But so I have the functions there, and then after I call my color function, which basically, you know, it basically says, hey, write this pattern of colors to the lights, then at the end of this main loop, it does FastLED show, which is basically a command from the library where it basically prints out all the colors to the lights, whatever we have set in the memory, writes it out, and then we have a delay at the end that basically says, all right, don't immediately start the next loop. Let's give it a little bit of time for things to change. So this basically controls how much time in between updating cycles of lights. Again, it's in milliseconds. So here I'm basically saying, hey, wait a tenth of a second and then run the code all over again. And because I don't have anything else in here, it's just going to keep running this color function, either, you know, pulse red, fade to green, whatever. It does that basically 10 times per second. If you made this delay longer, you say, you know, update once every second, then obviously the lights would move a lot slower, or they would change pattern. I could shorten it, and then the lights would go really fast, or at least as, you know, fast as the Arduino processor can allow. One other thing I wanted to point out before diving into the actual code, there are ways up at here where we have our declarations. Any declaration that you put in the code up here, it's a global variable basically. So I set for my individual functions, and we'll get into that. I set individual variables between them to control the behavior for that individual function. I could have created, all right, you know, one global variable to track how much red, how much green, how much blue is being output to the lights. That's certainly a way to do it, and like I said, thousands of ways to program things. For the purpose of the function, though, I use static variables within the function, and we'll talk about that more in a second. But let me just, for demonstration purposes, I'm going to throw something into the simulator. So let me grab basically my entire code. I'll leave the block at the top alone, right, because I don't want to change the headers for this virtual function or the simulator. So let me just take everything that's in the simulator, delete that. Now I'm just left with the header stuff at the top, and then I replaced it with my own code. I don't need this comment at the top, and I get this twice. So for the first example, say I'm running in this void loop. Jack's already done this example, right? You could run through a for loop that basically says from I equals 0 all the way to the total number of lights, I'm going to set the color of each individual light to color RGB 25500, so that's full red, no green, no blue. So basically set the color to red, and then it loops through all the lights and turns them red. So I could uncomment that, and it would basically write red to the entire LED strip. What I'm doing instead is I'm going to run this command, fill solid. Basically does the same exact thing, but it's much simpler code. This is fill solid is part of the FastLED library. Formatting is a little bit different, but basically one statement I'm saying, alright, set all of the lights in this strip to this color, which is all red, and then no green, no blue. And so if I click run code, I can see down here it says it's building the program. And of course live demo is a little bit slow, so I'll just give it a second. So it says program running, and again I have that 3-second delay for it to initialize, and then it sets everything to red, and then that's the only thing in this loop. So then it, writes red to the strip, comes back every 1/10 of a second, cycles back, writes red again. So lights are basically solid red. That's all I did was, so quick example there, setting it to solid red. And then what I did for kind of a intermediate example before we start working on fading from red to green, I created this function called pulse red. And let me just run it first. So rebuilding this again, and then we'll send it to the simulator, and you can see, alright, now code started, there's that delay, fades to red, and then it fades out. So pulse red basically blinks the red on and off, but it doesn't do it immediately on, immediately off. It kind of comes into red, and then dims it, and then brightens back up again, and just continues in that repeating cycle. And so I wanted a function that would do that kind of as a setup before I started messing around with adding the green. So let me stop the code there and we'll walk through it real quick. I'm going to do this in Notepad++ because I think the colors will probably make it a little easier to follow. So my pulse red function, like I put in the comment at the top, gradually increase the red to max, then decrease it to off, and then just repeat that in a continuing loop. So the first line here, basically declaring my variables. I use static integer and then the name of the variable and set it to 0. The static is important because that basically says, hey, I'm creating this variable, I want it to maintain itself. So even when I'm done with this pulse red function and gets to the end of it, don't eliminate that current red variable. Keep it. And so I only have to declare it once. Again, I could have made this a global variable, put it up at the top, but putting it static makes it independent for this pulse red function, separate of any other loops or functions that I might be calling it from. And then it's an integer, which means it's a number, and I'm setting it initially to 0. So initially red would be off, and then I have a separate variable called current change. This variable is used to control the amount that the red increases every update cycle. And I picked 15 just because, so every time it basically loops through this pulse red, it's going to increase the value of the red by 15 integers. I picked 15 because 255 is the max value for the lights, and 255 is evenly divisible by 15. But there's also smart logic to control if it's not evenly divisible. We'll get in a second. So again, declared the variables at the very start, and then for every time I call this function, it's only, because these are static, only declares those once. So the next time it runs the loop, we're going to take the current value of red, which again is 0 to start, and then set it equal to whatever it currently is, so again 0, and then add our change value to it. So it increases it by 15, and then the next time it runs through this loop, it's going to call that again. So it's basically going to keep adding 15 to it every time. And then we'll skip over this if statement real quick, and then at the very end of it, we run that command again, fill solids. So we're saying, hey, write to that LED light strip whatever the value is of red, and then because this is the pulse red function, I'm always writing 0 for green, 0 for blue. So again, keep going through this loop. So basically every time it runs this loop, it's going to increase the value of red that's stored in this variable. If I want to slow down or speed up, or basically alter the speed of how quickly the lights fade from nothing to full brightness, you could lower the number, which means it would take longer for it to increase, or I could change the number to be much higher. Obviously, right, if you keep adding 15 to it, eventually you're going to hit the max value. And so how do we control that? That's where I wrote this if statement where I say every time I add my change amount, so in this case 15, to my variable, when I'm done with that, check to see what's the current value of that variable, current red. If it's equal to or greater than 255, which again is the max value for the lights, in that case, right, I want to, red is now maximum brightness. What I want to do is start decreasing the color of the lights. So what I do is, just in case I exceeded 255, so say, I'm adding to it and all of a sudden it's 260 because I'm maybe adding 20 at a time or something like that. I don't want to write 260 to the lights because the light isn't going to understand a value of 260. 255 is the highest it can take. So the first thing I do is set current equal to 255. So make sure it's the max value, don't exceed that. And then I take the change value, current change, and I set it equal to its existing value. So it starts off with 15, and I multiply it by -1. So now all of a sudden my change value has gone from 15 to -15. So the next time, right, that I loop through this, current change is now -15, and then, right, current red is going to be 255, and when I add -15 to it, it's going to start subtracting. And so that's how I'm controlling it to basically start dimming once it's reached full brightness. And then similarly, in my function, right, every time I loop through it, it's going to keep subtracting 15 from the value of the red. And so eventually it's going to get to 0 or below, depending on how I have the how large I have the change value set. So I have another statement that says if the current value is less than or equal to 0, again, I don't want to write a negative number to the LEDs because that'll confuse it. It's not going to understand a negative number. So I force red to equal 0 just to make sure I don't drop below it. And then again, I multiply the current change value to be itself times -1. So now, if it was -15 times, a negative value, it's going to now become +15 again. And so then I'll basically start brightening the light again. That's basically it for the pulse red. So again, it's a function that when we run it, all it's doing is increasing the value of that current red variable until it reaches max value. Then it flips the change amount to decrease itself, and then constantly loops around like that to get the lights to create this pulsing effect. So from there, trying to figure out, all right, how do we do an effect where it fades from red to green? And I wrote 2 different functions, and there's a lot of different ways that you can achieve this. But right, the first thing to ask, right, is when we're sending values to this LED, there's nothing, at least as I'm aware, in the fast library that says, all right, this is, run a function and it changes from one color to another color. You have to, programmatically figure out, how do I write color values to get it to gradually change from a red value to a green value? And I wrote 2 different ways to do that. The first way that I wrote in fade red to green, I basically did the same kind of logic that I did with the pulse red, where I take the value, assuming for this the light starts fully red, and I subtract 15 from it every time. And then while I'm doing that, I'm increasing the green value by the same amount. So here's a RGB slider tool that kind of demonstrates what I'm doing. So basically, this is the value at the first cycle. Light is totally red. Say I run the function one time, what I'm doing is I'm changing red to be slightly dimmer, and I increase the value of green. And then the next time it runs that loop again, it's going to do the same thing. Decrease the value of red, increase the value of green. And then you keep doing that. Eventually, you're going to get to this point where they're both around the midpoint, right? Because we're increasing them and decreasing them at the same values every cycle, and you kind of get this faded yellow effect. And then eventually it's going to cross over and just become more and more green. And let me just run the code and we'll see a demonstration of that. So that's one way to kind of get that fade effect. So let me go back up to the top. This is our loop again. I'm just going to comment out the pulse red, uncomment fade to green. So now when I run the main loop for the Arduino, it's going to run my fade red to green code. So here we are building the program again. Alright, program running. So it starts off, well, it goes pretty quickly, so I'm not really going to be able to stub it. But, right, you can see this effect now where it starts out red, starts fading, comes yellow because we're adding green as we subtract red. Eventually it becomes full green, and then it reverses the pattern again, right? We're going to flip that current change value so that it's negative and then goes in the opposite direction. So eventually starts increasing the red again, decreasing the green, and then it just goes back and forth, and you kind of get this fade from red to green effect. One thing that I didn't do that I do in the other example is, right, if you wanted a fade to red to green, right now it's basically just a rainbow of colors pulsing. What you would probably want to do is get it so that when it becomes red, you kind of stop at red for a while, wait maybe a few seconds, run the commands to fade to green, and then wait at green for a few seconds, and then go back in the other direction. Right now it's basically just constantly moving back and forth between the two, which is an interesting effect, so I decided to keep the code that way. And then you can always modify the code yourself to kind of get the actual effect that you want. But let's step through this example real quick. So again, I added another static variable. I called it current green. Start this one at 0, and again, red starts at the full value. And for my starting change value, I set it to -15. So when I run through the change amount every time it loops through this function, I'm going to say red equals red plus, in this case, -15. And then when I want to do the opposite for green, I just subtract the value. So, right, green starts at 0. If I subtract -15, I'm actually adding 15. So while red is decreasing, green is increasing. When I flip the value for current change, it's going to go in the opposite direction. And so very similar to the pulse code, right? I want to check when do I reach the maximum value for red. And then, right, same thing, make sure red is the maximum value, green is at the minimum, and then flip the change variable to the opposite sign so it starts going in the other direction the next time it loops through it. And then same thing, if it reaches the minimum value, again, make sure you don't go below it. So if it's less than or equal to 0, set it to 0. Make sure green is also at the max, and then again, flip the direction. And then at the end of the function again, every time it loops through it, I'm going to write, hey, these are now the updated values of, red and green. Write them to the LED strip. And then again, in the actual loop code, when I exit that function, I wrote that to the LED strip, and then I have to run the show command to actually print it out. And then here's our delay again. So the last example that I wrote is a bit more complex, but also has more control in how you run the lights. So this one is Fade to Green version 2, and let me demonstrate it first, and then I'll step through the code to show what we're doing. So again, it reset to nothing. Alright, so it starts to red, kind of fades out, then goes to green, green fades out, and it goes to red, right? So this is a different way you could achieve the effect of fading from red to green. So instead of constantly increasing red to green, or instead of decreasing red as green is increasing, I basically said, all right, let's take red as my starting point. I'm going to decrease the value until it dims to nothing, and then I'm going to start increasing green. So that's basically how this function works. And then when I get to green, I'm going to say, all right, hold on to green for a little bit of time before fading it again. We want to actually show everyone, hey, this is green. Leave it there. Then start decreasing green again. Instantly start increasing red. and then weight it red again, so that you can see that red light effect. And so that's completely different way of achieving this red to green kind of effect. Another way to do it would be decrease red gradually, and then maybe when you get to like the halfway point, all of a sudden at that point just instantly flip it so that now green, once red reaches 100 or something like that here, set green to 100 and then turn red off completely, and then start increasing green. So rather than waiting until you get to 0 light when the red scale goes down, maybe go down halfway or 2/3 of the way or something, and then just flip the color, because right, a dim red being swapped with a dim green, you won't notice as much, and that way you don't have to fade to black. So that's another way you could handle it. I didn't do that in this code, but something to keep in mind. So let me step through this code real quick. Here's our fade to green version 2. I wrote... This one uses stage or mode selectors to try to determine what behavior you're currently utilizing. I called it mode here. A lot of other code will refer to it as a stage to basically track, hey, what level, what mode of behavior, what stage of behavior am I in? That's this variable here. All it is an integer that says, all right, depending on what current mode is set to, that's going to determine what behavior this function runs through every time I call it. But before I entered it, I basically created these definitions of constants, so these values don't change, and I call them... I'm basically just giving names to the different modes that I have, and you can create as many as you want. The only... the key point is they each have to have a unique value, so none of these can have the same one. So that when your current mode is set to that value, you can call it in the code by name, and it just makes way more sense. So I created 6 different modes, 3 for each of the colors. I have one where it's dim red, so while our mode is set to dim red, I want it to constantly make red dimmer. I have a pause red mode where it's basically, hey, we're at completely fully lit red. Let's wait here a few minutes or a few seconds before continuing on. And then I have another mode that's called light red. So when you're in light red mode, it's basically going to say, hey, every time I call this fade to green function, I'm going to be increasing the value of red. And then I did the exact same thing for green. If you're in dim green, it makes it dimmer. Pause green, wait, don't do anything, and then light green, increase again. And then I also created another definition constant for, I called it pause time. I set it to 5. This one's adjustable on the fly. I set it to 5 cycles. We can set it to be 10 or something to be longer. It basically says how many cycles do I wait before continuing on, and you'll see the trigger for that. So this basically determines how long you have full red versus or full green before you start dimming it to the other color again. So I declared these again. They're declarations. They're constants. So I define them as global variables or global constants. I put them outside of the function. Technically, I guess if you wanted to be a good coder, you should probably put them at the top of your code along with everything else, but it doesn't hurt anything to put it down here. Just putting it outside of the function itself. I put it in the function code for fade red to green. It would call them every time, and we don't want to do that. That's just wasted CPU processing. So putting them outside it, we just declare these one time, and then here's our actual code. And again, I use static variables to control red, control green. Start off red at full value, start off green at 0, and again, this is the amount that we're going to change the color by. I have a timer that I set to 0. Again, this is going to be the clock that basically determines, all right, how long am I keeping my red or green colors before I continue on. And then again, current mode this is the variable we're using to track which behavior we're going to use. By default, I'm going to say, all right, start off by dimming red, because we're going to start with fully lit red, and then we're going to dim it, and then that'll control our behavior. So then after that is the meat of the code, and there's a lot of if statements here, and I'm going to try to step through it so that it makes sense. You could do this with a switch function for simplicity and I think readability of the code. I think it kind of works better to do in the if statements here, but so every time we run fade to green, we want to say, all right, based on current mode, what are we going to do with this with the lights? How are we going to change them? And right, by default, we're going to say the mode is equal to dim red. So we have a statement that says if the mode equals dim red, and you have to use double equal signs because this is a comparison. We're not setting the value of current mode. We're saying is it equal to, so we use double equal signs. And we say if the current mode is equal to dim red, we're going to decrease red by our color change value. And so it's going to, right, starts off at 255. It's going to get to this line of code. It's going to say, all right, I'm in dim red, so I'm going to run this code. I'm going to decrease the value of red to 240. And then it's going to say, has red reached equal to less to 0? No. So then it's going to exit the code. And then it's going to check to see, hey, is the mode set to pause red? No, it's not. Otherwise, is the mode equal to light red? No, it's not. Is it equal to dim green? No, it's not. So it's going to continue on. Then it's going to get to the end of the function. It's going to call this, the fill solid to write our current color values to the LEDs, and then it's going to exit out. And then it's going to loop around again. So basically, it's going to keep on doing that. It's going to keep decreasing red. Eventually, we want some way to change to the next mode. And so how do we do that? We have the command, or the if statement here, when red finally is equal to or less than 0. Again, we want this protection. We don't want it to be a negative value when we write to the light, so we force it to be 0. And then we're going to set the current mode to equal light green. Because, right, we've started off with full red, dimmed it all the way to 0. What do we do after that? Now we want it to start being green. So we write the mode light. We change the mode light green. So the next time fade to green is called by the loop, it's going to execute different behavior. So now mode equals light green. So the next time it runs the code, it's going to skip over this, skip over this. Eventually, it's going to get to light green. Light green. How does it work? It sets the current value of green equal to the current value plus our change amount. So green starts at 0, then it starts adding 15 every time. How do we exit this condition? It's going to keep increasing green every time we run. Eventually, we're going to reach the maximum value, 255 or more. So we check for that as part of the condition, and then we say, all right, green is more than 255, set it to 255 so we don't exceed it, and then set the mode. What do we want to do next? Now we want to pause green, wait at green for a little bit, don't do anything. So do that, and then the next time the function runs, now when current mode is switched, it's going to say, all right, current mode now equals pause green, and we're just going to increment the timer. So timer plus plus, it's basically, you could write timer equals timer plus 1, whatever. And again, the timer started with a value of 0, and it's going to increase until we reach pause time, is how I wrote the code. So once the timer reaches, in this case, greater than or equal to 5, we're only adding 1 at a time, so it should eventually reach 5. Reset the timer so that it can be used again, and then, right, we've basically waited 5 cycles where it's fully lit green. What do we want to do then? Next step, I want to start dimming green, so I set the mode equal to mode underscore dim green, and then what does that do? Pretty much what you expect. Takes the current value of green, starts subtracting the color change every time. Eventually we're going to want to get out of that, so how do we track it? Current green less than equal to 0, so once green has gone from full brightness to maximum dimness, at that point we're again set it to 0 as a protection, and then the next thing we're going to do is want to start lighting red. So what does the light red function do? Starts increasing the value of red. And so you can kind of see here, each time we have these mode if statements within the code, the basic control, what do you do when it's set to that? So they each have their own value, you can do different things. And that's where, if you want to play around with the lights, you can really do a lot of different things, right? Where I said, right, the first fade to red fade red to green function I wrote, right? It didn't stay at red. It just instantly got to red and then started going to yellow to green and then instantly started from going to green back to red. So we call the fade red to green, but right, it's kind of just a rainbow of colors constantly cycling. If you wanted to stop at red when it gets to the full value, you could use something like this where it's trying to figure out, have different modes or states of behavior where it figures out what to do. And so just cycling all the way around, when you've lit red all the way, eventually, when you've finished lighting red, it reaches the maximum value, then it pause at red. And then again, same thing. Just use the timer until it reaches that max amount of time, then start dimming red again. See if there's anything else I wanted to say. That's kind of it. There's definitely a lot of flexibility you could do with the code. Another suggestion that I was kind of looking at, in terms of ways to fade from red to green, one of the suggestions is you could leave red at the maximum value, basically increase your green, and you kind of get this kind of color gradient where it goes pretty much full yellow at one point and then goes to green, rather than having kind of a dimmer or a muddy yellow. Basically, they're saying instead of doing like halfway bits like I was doing before and just kind of passing each other until you get to full green, they were saying instead increase green until you get to the full yellow and then start decreasing red until you get to green. So it's just different ways to kind of achieve that fade from one color to another effect. So, again, it's code, so it's up to you how you want to do it. And again, right, you would probably want to use, mode statements or state checkers to figure out, what's my current behavior. Maybe I want to stay at red for a while before I continue on. But, those are some of the options that you have. Definitely play around with the code. I think that's it. Thanks, everyone. Until next time, do more, care more. Bye.